This is exercise number 21 on page 370, and we're supposed to find a quotient and a remainder in this problem. So we're given number 21, and basically they say this polynomial here, which is just our dividend, the thing we're going to divide by, is equal to what we're dividing by, the divisor, times the quotient, and then plus a remainder. Well, this is all division, right? If you divide by something, you get an answer that's the quotient, and when you multiply back your answer, the quotient, by the divisor, you get back the original dividend. And if it doesn't divide evenly, if your divisor doesn't go evenly into your dividend, you'll have a remainder. So when they say find Q of Z in this, it means find the quotient, which means to divide. Okay, so divide the dividend by the divisor. That's all that it means. So the divisor is Z plus 2I. So if I put that in x minus c form, it's Z minus negative 2I. So the negative 2I goes in the box. And so now the coefficients to the dividend are 2z to the third and negative 3z squared. And I'm going to spread these out horizontally because of how these problems have, we get complex numbers. Let's see, plus 8z to the first, so positive 8, and then negative 10. And my remainder will go down here. So bring down the 2. 2 times negative 2i is negative 4i, and I'm combining a negative 3 and a negative 4i is the complex number negative 3 minus 4i. The real part's the negative 3, the imaginary part's the negative 4. So now I'm going to multiply negative 3 minus 4i by negative 2i, and I'm going to be really careful. I'm going to do that out here on the side. I'm going to take the negative 2i and multiply it by negative 3 minus 4i. So this is 6i, and then negative 2i times negative 4i is positive 8i squared. Because I squared is negative 1, that becomes a negative 8. So I have negative 8 plus 6i. So when this is multiplied by c, I get negative 8 plus 6i. So combining going down, 8 and a negative 8 goes to 0, and I just have a 6i. So now I'm going to be multiplying the negative 2i, the c, by 6i, and I get negative 12i squared. I squared, of course, being negative 1, makes that a positive 12. So a 12 goes here, and combining going down, negative 10 and 12 is 2. So here's my remainder. This is the constant. This will be the z to the first and a z squared. So my final answer, the quotient I was asked for, is 2z squared, and then this is the coefficient to the z. I can make that pull the minus out to the front and make this 3 plus 4i. You can see how this is a negative 3 and a negative 4i times z. The constant is a positive 6i. And the remainder that I'm asked for is a positive 2. So that's number 21.